Hello, I'm Bernice German, the Math Whisperer. This is where math makes sense. Welcome to Adding Fractions, Part 2. Adding fractions is more difficult than multiplying them, except in a very special situation. Adding fractions is relatively easy when the denominators are the same. Here's a fraction, a over b. b is the denominator. The only way to add fractions is, wait, let me. A over b added to c over b equals a plus c over b. Yes, a over b added to c over b equals a plus c over b. If you don't understand this, please watch my video, Adding Fractions Part 1, where I explain this in depth. Here's an example with numbers. 1/5 plus 2/5 equals 1 plus 2 over 5 equals 3/5. 1/5 plus 2/5 equals 3/5. We have a unit or label, fifths, to call the sum. This is the same situation as adding apples. 1 apple plus 2 apples equals 3 apples. We have a unit or label, apples, to call the sum. And this equation shows the pattern for adding fractions. The denominator b is the same in all cases. The b's are the units. So what do we do when the denominators are not the same? I don't know. What do we do when the denominators are not the same? We have to make the denominators the same. That is why adding fractions is complicated. With different denominators, the algebra expression is a over b plus c over d equals what? An example with numbers is 1/4 plus 2/5 equals what? This is the same situation as 1 apple plus 2 oranges equals what? What do we call the sum? We have to find a unit or label that includes apples and oranges. To do this, we need to bring in new information. We can use pieces of fruit. We had to know that apples and oranges are both fruits. It's the same with fractions with different denominators. We have to bring in new information to find a common unit or label for the sum. To get this new information requires two things. 1, how to multiply fractions, and 2, how to find equivalent fractions, which requires multiplying them. So you can see right here that adding fractions is generally much more difficult than multiplying them. We need to find a way to put these fractions in the form for addition of a over b plus c over b. We need to find a common denominator, a common b. For 1/5 plus 1/4, 20 will work. How do I know? Well, I've done a lot of these. And I know that if I use a common denominator that has both of the original denominators as factors, it always works. That's a lot of jargon, and doing it is more simple. Put simply, 4 times 5 equals 20, and 20 will work as a common denominator. Here's how to make it work. We start with 1/4 and then use a magic 1. A magic 1? I love magic. I pull a 1 out of my pocket. I can pull a duck-billed platypus out of mine. 1/4 equals 1/4 times 1. Wait, 1/4 equals 1/4 times 1? Now we use the form of 1 that gets us to the denominator of 20 that we want. Another way to write 1 is 5/5. So we multiply 1/4 times 5/5 and get 5/20. 1/4 and 5/20 are equivalent fractions. We're halfway there. Now to find an equivalent fraction for 2/5 that has a denominator of 20. We start with 2/5 and then use the magic 1. 2/5 equals 2/5 times 1. We use the form of 1 that gets us to the denominator we want. And that form of 1 is 4/4. Back to 2/5 times 1 equals 2/5 times 4/4 equals 8/20. 2/5 and 8/20 are equivalent fractions. Now we can add. We have apples added to apples now, and we can add. We have a common denominator, so we can add. Using our algebra formula, a equals 5, b equals 20, and c equals 8. A plus c equals 13, and the sum is 13 over 20. As you have seen, adding fractions is not simple or easy when the fractions have different denominators. You have to know how to multiply fractions to do this, and you have to have an understanding of equivalent fractions, which requires multiplying them. Not simple at all, but you can do it. And here is our final example. 3/10 plus 2/15 equals what? We need a common denominator. It's helpful to find the smallest number for the denominator possible, as smaller numbers are easier to work with. To find the smallest common denominator, I'm going to factor the 10 and the 15. The two denominators have a common factor of 5. A denominator that has factors of 2, 3, and 5 will be the least or smallest common denominator. Once again, we will need magic wands to make equivalent fractions. Three tenths plus 2/15 equals 9/30 plus 4/30. Using our algebra formula, a over b plus c over b equals a plus c over b. A equals 9, b equals 30, c equals 4, and the answer is 13 over 30. 13/30. Now what happens if we don't find the smallest or least common denominator? Does the sky fall? Do we get the right answer? The answers are no, the sky does not fall. And yes, we will get the right answer if our arithmetic is correct. To check this, what if we choose a denominator of 150, which we select by multiplying the current denominators of 10 and 15? Then we will use different magic wands. We have a common denominator of 150, so we can add. The sum is 65 over 150, which is not in reduced form. Now we have to reduce this sum. I will factor to do this. There's a magic 1 in the form of 5/5 here. Since 5/5 equals 1, and 1 times any number equals that number, 65 over 150 is equivalent to 13 over 30. We get the same answer no matter what denominator we use to add, since our arithmetic was correct. So in summary, the way to add fractions is a over b plus c over b equals a plus c over b. The b's, the denominators, have to be the same. It's helpful to have the common denominator be as small as you can get it. But even if the common denominator you use isn't the smallest possible, if you do the arithmetic correctly, you still get the right answer. And there you have it, my very brilliant math student.